And it's supposed to be less.
Okay, are we ready to get started? We're going to finish chapter 3. Thursday, we'll do a little bit of chapter 4. Week from today, quiz 2. All right? Chapter 2, 3, and a little bit of 4. Whatever part we cover up for. What do we got here? Free tutoring. If anybody feels they're going to need it maybe after the second quiz, possibly. You know what that means? There's a web page for it. You just schedule, it's free, and you can get free help. Good time to do it right before a quiz. Helps a lot of people, especially if there's anybody trying to get a group together to study right before the quiz. That always helps a lot of people. All right, where did we leave off? Chapter 3, interpreting the output and the analysis. There's a couple of areas, a couple of items new that you're seeing for the first time, and that is sunk cost and relevant cost. And I'm thinking to myself right now, what would be a kind of an interesting way to describe this? So I'm going to try something different. The dual prices, before we get started, tell me which particular constraints happen to be the binding constraints. 1, 2, 3, 4, there's only 3 there. 1 and 2, and they knew that so quickly because they saw what someone else?
The zero.
That's right, zero slack and surplus. Then that's how you know quickly that's the binding constraints. You know, if you see an output on your quiz, it's probably one of the questions that are going to be underneath that output. Look at the output above. Which number constraints are the binding constraints? 1 and 2. Takes you that fast. Now, the dual values, I want to make sure you understand there's another name for those dual values called shadow price. So if you see any, in the PowerPoint mentioned shadow price, I think the book mentions shadow price, and I haven't brought it up yet, but I just want to make sure you realize we're really talking about the dual value, which I call dual price. Well, the dual prices have, what you've learned last week is, if there's here's our right-hand side values, correct? If there's changes in these right-hand sides, it's all about, hey, did those changes cause those dual values to no longer be valid? Or did the changes, maybe they're within their limits, and if there's more than one, we'd have to do a 100% rule, and those dual values could be still valid. And the dual values are trying to tell you what kind of change you're going to have in that objective function value, that 8,400 at the very top, based on the number of units of change of the right-hand side of these constraints. For every 1 unit of change, that's the effect it will have on the objective function value. But these shadow prices, or dual values, have another function. The other function is that you're going to get called, possibly if you're in this particular industry, that you're going to be using this kind of stuff, and the call will say, hey, I have some additional resources, whatever it may be. A lot of times it's a supplier with additional raw materials. And they'll say, I know I was supposed to drop off 80,000, but I got an extra 10,000. Let me look here. 10,000. Your first thing, and they need to know right then. Are you going to take it? And we're offering it to you. We're offering you these 10,000 extra units for $9,000. All right. Now, you've got to make a decision fast. First thing you got to do is say, is my dual value or shadow price still valid? Yes or no? Not all at once. That was way too fast. Come on. Well, is the dual price still valid?
Yes.
Let me hear you.
Yes.
Yes.
Yes. Why?
Within the allowable increase.
That's right, because the increase is within the allowable increase. Now, hopefully you're starting to recognize how some of these outputs have the current value in the middle, upper limit and lower limit in values. But some of these outputs have the current value here, and they are telling you the allowable increase in units and the allowable decrease. So It's kind of telling you the exact same thing as the other outputs, just stated in a different way. If this were the other output, the upper limit would be 80,000 plus 60,000, 140,000. The lower limit would be 80,000 minus 15. What's that, 65,000? If it were the other output. So you got to make sure and look at this carefully. You don't know which output's going to be on your quiz. And in real life, there's like 15 different type looking outputs. They're all giving you the exact same information, just in different ways. And once you get familiar with this, you can read any of these outputs. You go, oh look, there's the objective function numbers right there. Oh, so there's where the part is giving you how much it could increase, how much it could decrease. Oh, there's the section with the right-hand side of the constraints. It'll just be in a different spot. And it may talk about upper limit, or it may say this is how much it can increase. And they'll always have these dual values. Sometimes we'll say shadow price or dual price. As long as the dual value is still valid, 80,000, we're being offered 10,000 more. It's within the allowable increase, so we know that's going to be accurate. And they're saying they told us $9,000. If the dual value or dual price, and this whole thing, and in the problem, if it says it's a sunk cost, then the dual value, that dual price, is representing the most you should ever pay for each additional unit that could be offered to you. So what do we tell the supplier? Yes or no, we'll take it. Come on, I just gave away how you should figure this out. You ready? I'll say it again. This is a sunk cost, not a relevant cost, which we're going to talk about in a minute. And the dual price represents the absolute most you should be willing to pay, because if you pay more than that, there's no benefit to getting the additional resource. You'll be losing money on it. So my question for you is, they just offered us 10,000 more units for $9,000.
Yes.
If you're in a hurry, yes. Was that Joanne who said that?
Yeah.
Yeah. She quickly said 10,000 units times 9 cents. Wait, is that 9 cents?
9 cents.
It's not, oh, I thought it was $9.
Yeah,
Sorry, I set you up. My fault. It's take 10,000 times 9 cents. Tell me what you get. $900? Is that $900? Yeah, we're never going to take it. My fault. I meant to say 900. Now, Joanne, $900 they said. Yes, because you would take the number of units times the dual value and figure out what's the most you're willing to pay, which would be $933.33. But you've been at the job now for longer than the rookie amount of time, and you're through your training process, and so you know you need to negotiate a better price, but in the back of your mind, you're going to take it. All right, you know you're going to take it, but you're trying to get the best price you can. So you're going, well, I can make a decision right now and give you 8,000 or 800. 800. Save us 100. Do something. But yeah, you're going to take it. But that's how quickly you can answer these questions when it's a sunk cost. All right. How do we feel? Want to do one more before I go to relevant? All right. Second constraint. Boy, I hope I don't blow this one. Second constraint, supplier calls, offered us 50 additional units. And they said it will be $75, right? So my question for you is, first of all, is our shadow price or dual value still valid? Yes or no? Why is it still valid?
Because 50 is less than 75.
That's right. Allowable increase is 75 units. They're offering us 50 units. We know that's still valid. They told us, how much money did I say? $775? Is that what I said? $75? Are we saying yes or no right off the bat? No. No way. The most we should be willing to pay, 75 for 50 more units, is that what I said? 50 more units would be $1.33 per unit, which would be 50, a third of that, whatever, 60, whatever that adds up. Was it add up to?
65 or so.
Thank you, about $65. So they're telling us $75? No. We're going to say, I can tell you no right now, but if you're in a hurry, but if you got a minute, let's try to negotiate this and get a good price. If you're a buyer, this is what buyers do. For big companies, a great job as a buyer. In the old days, you would get gifts because they want your business so bad that No more of that's all gone. That's in the old days. I know this because when I was a real little kid, my dad was a buyer for General Motors for a little while, and we would get gifts dropped off at our door all the time. And I was going, Dad, what's going on? Oh, you know, they appreciate the business, you know, something like that. So, but they, you know, companies realize that's unethical and cut that all out. At least good companies would cut that all out. But in the old days, a lot of free golf and all kinds of things. All right. I think you got it. When it's a sunk cost, it's that fast. You just look at the dual price, multiply times the units, and you can make a decision whether to say yes or no. Okay? Here's the tricky one. Relevant cost. How will you know if it's sunk cost or relevant cost when you're reading the quiz? In business, you'll know. You've been to the meetings, you've done this so many times, you'll know if it's relevant or sunk cost. But on the quiz, it will say, you know, it may be really obvious if the word sunk or relevant will be in the question, most likely. If not, there'll be description like, the supplier called, they said they're about to drop off your 80,000 units, they're offering you 10,000 more units, and you usually pay, hang on a minute, you usually pay 10 cents a unit, pound, whatever it is, you usually pay 10 cents a pound, but for these extra 10,000, they're going to charge you 15 cents. Do you take it? You know, there's no negotiating because it's a quiz question. Do you take it, yes or no? When it's relevant cost, the shadow price or dual value or dual price, whatever you want to call it, is the most you should be willing to pay over and above, called a premium, to whatever the regular cost would be. So I said in that little scenario, the regular cost I said was 10, did I say 10 cents?
Yeah.
10 cents, but we have to pay 15 cents. If it's relevant, do we say yes or no? If I haven't confused you, you think you get it, tell me what you think. Yes or no?
Yes.
Because, that's right, the 15 cents is how much over our regular price we pay, which is 10 cents. How much they're asking us to pay how much over our regular price we pay for this for this raw material, whatever it may be. 5 cents over. And this says you're willing to pay up to 9 cents over, and it will benefit the company. As long as the amount of units are within the limits.
Then how do you know if that question is about something else?
That's right. Like I said, you've got to. If you know, for this quiz, I'm sure I'm going to make it obvious somehow.
Okay.
Either I'm using the word relevant or I'm using the word sunk, which will most likely be the case. I always say most likely, so I don't get crucified if I accidentally didn't say it. How about this? If there isn't a word there that says relevant or sunk, we're assuming sunk cost. We're assuming that that's the most we would pay for it. It has nothing to do with premium or above the regular price. Believe me, I'm going to try to put the word in. But if it's not there, we're all agreeing to assume it's sunk cost. If I forgot. Okay? Let's do another relevant cost. I want to make sure you get this. Yes?
So, so sunk cost means that the dual value is the absolute highest price you'll pay for it.
That's right.
Relevant cost is saying that's how much you pay over what you normally pay.
That's the most you'll pay over the normal pay on a quick decision like that, and you know that it will benefit us. We'll make money off of it.
Okay.
All right? So we'll go to constraint 2. They're about to drop off 700 units, and they said, hey, we got an extra 100 units, and we want to know, you usually pay $5 for it, but we're going to charge you $6 for it. Do we take it, yes or no?
No.
No.
Hear all those people say no right away, but wait a minute. Our regular price is $5. They're offering it to us for $6, which is only and it's relevant cost. It's only $1 more than what it says here, but what they caught, without being tricked, is that I said they're trying to send us an extra 100 units. And that we cannot rely on that $1.33 because the 100 units will take us over the upper limit. And that is no longer valid. And I'm sorry, I cannot take this at this time. You know, I'd have to redo this whole calculation to make this decision. And they're telling you, I'm going on to the next company. You know, we're offering it to the next one. And say, okay, well, you know, it's the best I can do right now. You're offering, I'll take 75 of it right now for $6, right? Yeah, I'll take 75 units right now for $6 if you need to know an answer right now, this quick. And that's usually the case. Let's try another one because I know I've lost a couple people by trying to be tricky. Let's do it again. Again, with the second constraint, this supplier, we're supposed to be getting 700 units, and we just they just called and offered us 10 more units. We usually pay $5, and they offered it to us for $6.50. Yes or no? No again? Well, I just said 10 units. It's within the 75. We're within the limit. So that $1.33 is relevant cost. We usually pay $5. They're offering it to us for $6.50, I said, which is $1.50 more, and relevant cost means that that's the most we're willing to pay over and above the regular price. If it's usually $5, the most we're willing to pay then is $6.33, correct? So $6.50, if we don't get the chance, if it's a quiz question and we can't negotiate the price, we're saying no. $6.50 is more. We would lose money on the deal. It wouldn't be beneficial to us. Our profit, our maximum profit, would only gain $1.33 for each additional unit. So why would we pay $6.50? It's like setting us up for loss. All right? How's that? Another example. This one's too easy now after you've seen all that. Let's see, we're going to this one right here. This is a bike company. They have the deluxe and the professional bike. Their anticipated profits are $10 for every deluxe they're going to put in the cycle here, this next production cycle, and they know sold. $15 for every professional. Trying to figure out which combination we should make in this next production run. We have to use some alloys in the production process. They happen to be aluminum and steel. Our supplier is dropping off 100 pounds of aluminum, and our other supplier is dropping off 80 pounds of steel. However many deluxe bikes we're about to make, it will take 2 units of aluminum and 3 units of steel, or pounds, for each one. So however many, 2 times however many, and plus 3, of aluminum. Professional, 4 units of aluminum, but only 2 pounds of steel. It's a lighter bike. The aluminum is more expensive. This is why this is kind of a premium frame. We're making more profit off it because we're charging, a premium price for it. However many professionals we decide to make using 4 pounds of aluminum, and then however many deluxe, 2 pounds of aluminum, so 4 times however many of that bike plus 2 times however many of that bike, it's got to be less than equal to what? 100, because there's only 100 pounds of aluminum being dropped off. There's a constraint. However many professional, we're using 2 pounds of steel. However many deluxe, we're using 3 pounds of steel. When we take those times, their variables, add them together, it has to be less than equal to, because that's all the steel we have. So the combination of bikes we're going to make have to be within those raw materials. Where's this profit coming involved, though? What about this $10 and $15? How does that fit in? If we were writing a linear programming, how would that fit in? I heard a couple answers here, but I think I heard both right. It is. It's going to be our objective function. Our whole deal is we got to meet the limitations of the amount of steel and aluminum we have, but whatever combination we're going to make, we want as much profit as possible. Maybe there's more to the story. Maybe we got to meet a customer contract that's already in place. Let's take a look. No, it just says how many deluxe and professional frames should we make. So let's write this up. Maximize $10 to $15 profit. We're going to use X1 for the, I forgot the name of it, not the professional, the deluxe, thank you. We're going to, X1 is going to be the deluxe, X2 is going to be the professional, I think. I already forgot that already. Now, we only have 2 constraints. This couldn't be any easier. 2 constraints. I'm going to guess that they're both binding possibly. No, they're both less than equal. All we have is that much raw material. And where's our output? Uh-oh. Hang on, I gotta find the output. We have to make our own output. Great. All right. This is a perfect chance for us to learn how to use Excel to solve this. No, we're going to use the software. We'll use Excel in the next one. Here we go. I want to do new. Easy. Someone's got the PowerPoint in front of them. How many variables? There was 2. How many constraints? There was 2. This is a maximization problem. Is that correct? The profit with X1 was $10. The profit with X2 was $15. All right. This is 100 pounds of aluminum. This was 50. No, thank you. 80 pounds. These are both less than equal. We don't do the equal. We just do less than. Whatever you do, don't hit your enter or return key. It just says error, and you got to start all over. So I'm using the arrows. I don't know if anybody's tried this yet at home with Lab Anywhere. Okay, how much aluminum does the first bike use? 2 units, and the other bike uses 4. How much steel does the first bike use? 3, and how much the second bike? 2. That's it, right? Everything look okay? Solution solved. Here we go. Which constraints are our binding constraints? First and second, 1 and 2, because they have no slack surplus. Are you ready? Now this output's a little different than the book. You notice that we don't have allowable increase, allowable decrease. Giving you the same information, just slightly different way. Matter of fact, tell me the allowable increase for constraint 1's aluminum. If it were to increase, what would be the allowable increase? 60, because it says the limit's 160. It's just giving us that full limit instead of the amount. The reason this is important, if you have the 100% rule, and this is going up, you're taking the amount it goes up divided by the amount it could have gone up. That's why the 60 is important for you to recognize. As a matter of fact, the first supplier called this. This output represents sunk cost. They're offering us another 20 pounds of aluminum, and they said $3 a pound. Taking it, yes or no? Good. Yes. First of all, you quickly are checking to see if those dual prices are still valid by looking to make sure that that additional amount's within the upper limit. I said 20 extra units or 10? 20 extra pounds is within the limit because it takes us to 120. We could go all the way up to 160. They offered it to us for $3 a pound. We don't even have time to negotiate the price, but we would. And they said $3 a pound. We look right up there and see it's $3.12.5 will we profit on every additional unit. So we're willing to pay, we'll make an extra 12.5 cents, bring it on, 20 extra pounds. When are you delivering it? I'm already putting it on the schedule. The steel supplier just called, sunk cost steel. They're offering us an extra 10 units at $1.50 a pound. Are we taking it, yes or no? No. Is the amount they're offering us in pounds within the limit?
Yes.
It is. Because they're offering us an extra 10, but they could offer us, which takes us to 90, but then we could go all the way to 150, which is an extra 70. And since it's sunk cost, we know that we'll gain $1.25 for each unit. They offered it to us for $1.50. We would lose 25 cents if we took that deal. And I know it's only extra 10 pounds, so it doesn't sound like a lot of money. But it would be a big deal to make a bad decision like that, because it's probably, everything's probably multiplied by 100 in the real world by what you're looking at right here. You ready? One supplier supplies us with both of these, and they're offering us an extra 50 pounds of aluminum and an extra 10 pounds of steel. And the aluminum, they're offering it for $3 per pound, and the steel, they're offering it for $2 a pound. Your first reaction before you do any calculating is yes or no, you want to take this. What? What did I do wrong? I meant $1. Did I say 2?
Yeah.
Sorry, I meant 1. All right, now it's 1. Your first reaction is, and they're saying, this is a package deal. Either take it or lose it, all of it or none of it. Your first reaction is to say yes, right? Because you quickly looked and said, oh, the 50 pounds of aluminum is within the upper limit, the 10 pounds of steel is within the upper limit, these numbers are still valid, I know it's sunk cost, the problem said sunk cost, both prices are under the dual prices. Your reaction is to say yes, but if you didn't take the time to do the 100% rule, you could be making a major mistake. Because anytime you have more than one change taking place at the same time, you've got to measure the 100% rule. So you quickly got to go, and I don't know if you did that when you answered it. 98%?
It's really like 97%.
All right, so, and what he just is doing, he took 50 increase, but it could go up how much? 60 units. Help me out, that's going to be
83.
0.83, thank you. And then we have 10 units, but it could go up 70 units. So that's 0.114. Where's my calculators?
Yes.
Thank you. 83% plus 94, maybe. We have no confirmation yet. I'm just taking much word here. All right, 97-ish percent maybe, or 0.97, however you want to look at it. It's under the 100% rule. We're taking it. Unless you got time to negotiate, we're taking it. Unless you see the window of opportunity in negotiation, which always exists. But we're basically taking it.
Should we worry about the 100% rule with the dual prices?
Oh, yeah, always. Anytime there's more than one change taking place, you have, no, you don't have to do, the 100% rule is only, when it comes to these constraints, is all about knowing whether those are still valid or not, as sunk cost or relevant cost, in this case it's sunk cost. We did this so that we know those are on the button. They're accurate, and we know that we're being offered each one for $3 a pound and the other one for $1. They're both under that dual price, and we're, yes, give it up. Make it happen. Send it on over. Let's do it. So we'll have to recalculate things to change production, but no matter what happens, we know we're making money off those additional units. Because that whole thing we just did is just to make sure those dual prices are valid and we can make a quick decision. You know, we're no longer making 15 and 17 and a half because these are changing. And so we're making more. And we'll recalculate things while we're waiting for the rest to show up, these new materials to show up. But we made a quick decision. We made sure our competitor didn't get that aluminum steel. And we know we're going to make money off it. And we're changing the production schedule. But we could make the decision fast because we know how to figure out if those dual prices are still accurate. You want to do it one more time now with relevant cost? Relevant? You ready? Nothing changed. You know, I don't know how to be creative here. I'm just going to say nothing changes except for the prices we're being offered. All right. There you go. $3.10 and $1.50. We usually pay. Hang on a minute. This is how much is being offered over and above our regular cost. When someone's talking on phone, though, it's like this. What did I say here? 50 units. We usually pay $10 a unit, let's say. $10 a unit, and they're, forget this, and they're offering it to us for, hang on, 150, so that's going to be $650. These 10 units, we usually pay, I'm making it easy, $10 a unit, our usual price, and they're offering it to us for $110. Still 50 units, still 10 units, still upper limits are still the same. We're still under the 100%, correct? We usually pay $10 and $10 for this. That would never be correct. We would always pay more for the aluminum, by the way. $10 and $10 per unit. They didn't give us a per unit price. They just said $650 for this additional 50. You want it? We got to figure out what's the most we would ever accept it at. And so we take that $3.12.5 plus the $10, which would be $13.12.5. Let me get the calculator out here. I already forgot. $13.12.5, is that right? 13.125 times 50 units, because usual price. The most we would ever want to pay for this and break even, and we never want to say yes to break even, $656.25. They offered it for $650, but this is a combination offer. You take it all or none. And I want to tell you real life for a second. Even if one of these prices are slightly above what this turns out to be, if there's enough profit on the other one, then we would be willing to take a loss on one of the others, as long as the loss is smaller than the profit we would make on the other one. You see what I'm saying? So even if the price ends up, this isn't going to end up above it, but I'm just giving you a fair warning what could happen in real life. You still would take it. So now we're taking, this is usually $10. we're willing to pay $1.25 above that price. So that'd be what, $11.25, is that right? $1.25 above regular price times 10 units. We would be willing, we don't want to let the supplier know, but the most we'd be willing to pay for this one's 112. They offered that for 110. We want both. Bring them on. What I'm trying to say to you in a real scenario is they offered this for $114. The most we're willing to pay is $112.50. But we're making enough profit on the other one at $6.50. I can't remember what we calculated is the most we paid.
656 something.
So because we're up, let's say this is all in thousands, because we're up $6 on one, 6,000, even though we're going to lose $1.50 is all we're going to lose on the second one, we're still going to take this deal. The profit on the first one outweighs the loss on the second one to the point if this is a combination deal and the only way we can get is to take both of these, we're willing to take that small loss because of the big gain we're going to get on the other one. So we'll do it. If this is all, if we can't negotiate it, we'll take it.
Will we see something like that on an exam or?
Yeah, anything we talk about in here, you're going to see.
Well, right,
Yeah.
but are you going to want us to accept it on an exam or a quiz? Or are you
Absolutely.
Okay.
Yeah, logic's in place.
Okay.
You would in real life, absolutely. And here's how if someone says, oh, why'd you do that? We're going to lose money on that deal. You're going to justify. You say, look how much profit we're making on this one. The only way this deal could happen is if I take both. Whatever that loss is nowhere close to the gain I'd make on that one. You would be crazy not to take it. We're going to come out ahead. Why wouldn't we take it? In real life, there's other things taken into consideration. Do we have to get into overtime with the additional ones we're going to make? Blah, blah, blah. But anyway, do everybody see now how this is done and how these numbers are used? This is actually the end of interpreting the output. You've learned everything except for reduced costs, which we're not going to cover in this chapter. But everything else on this whole output we've covered and talked about and how to use it. You're all experts. Okay? Now, before we get into a lengthy in-class assignment, we're going to learn how to use Excel to find the optimal solution.
So this problem originally started out by asking how many lots of professional units we should make. If we do homework, do we need to go through the process of like the addition and subtraction method, or can we just pull up this output, find the answer up there,
Yeah.
and then?
You're going to have an output just like this on the quiz, and you're going to be asked all those questions.
Yeah.
Yeah, but you don't have to calculate. You don't have to calculate the optimal solution, I think is what you're asking.
Okay.
You don't have to do the subtraction method, addition method, if the question is related to an output. Is chapter 2 on this quiz though? Yeah, if there's a chapter 2 question, you will. I almost feel very confident there's probably one question where it will say, use one of the 3 methods to tell me where these 2 lines will cross. So that helps prepare. So the answer is yes and no, isn't it? Right? Because you were asking if you would have to use one of those methods. The answer is yes, but not on a question like this. This question is going to be where you don't have to do the methods. You're already given where the 2 lines are crossing at 15 and 17 and a half. I don't know if I answered your question. I can't tell. Give me a look like it wasn't even the question you answered or something. It wasn't even the question you asked. I don't know. You want to ask again? And maybe I'll be able to understand it better.
I was just asking for chapter 3 homework.
Okay.
We needed to go through.
Oh, chapter
that
3
once we get
homework.
Yeah.
Yeah, chapter 3 homework should be just like this that we just talked about here, but much easier.
Okay.
Chapter 3 homework is based on last Thursday's lesson. All right? It's going to be, hey, here's a change taking place. What's the new objective function value? That's the add and subtract part. Here's a change taking place. What's the new objective function value? Here's a change taking place. What's the new objective function value? Here's a couple of changes taking place at the same time. What's the new objective function value? If it's under 100%. Remember, you do not do the 100% rule if there isn't more than one change taking place. The other class finished this chapter, and several people were doing the 100% rule, but there's only one change taking place, so it doesn't make sense. When there's only one change taking place, you're just looking to see if it's within the limits. And if it is within the limits, then you go ahead and calculate the new objective function value. You don't have to do 100% rule. Everything's still good. The objective function numbers is all about if the optimal solution, 15 and 17 and a half, are still valid. But the right-hand side of the constraints, this is all about whether those dual prices are still valid. This isn't about the optimal solution. These change the objective function value based on those, but the objective function numbers change the objective function value based on this, because 10 times 15 plus 15 times 17 and a half, there's your 412.50. But if one of these are changing, now it's that new number times 15 and a new number times 17 and a half to get the new objective function value. That's a little review. All right, going to Excel. I posted this on Blackboard. This is all set up for you to use it if there's two variables involved, 3, 4, or 5. You just get rid of what I put in there and you put in the information based on however many variables are involved. In this question, which one's this? The less than equal 16, the less than equal 19, the less than equal 8. Let me go back to the PowerPoint and figure out, is that first one? Is that one right there? 16, 19, 8, 5, and 7, right? Now let's see. So I took the 5 and 7. Oh, that's not true. That's not it, is it? Is that 6, 19, 8? Was that it?
Yeah.
Yeah.
Okay, this should be a 5 and that should be a 7 then, right? The objective function value with x1, I think it said 5. The objective function value with x2 was 7. Now I can leave these the way they are, but I don't want anybody to get confused, so I'm just going to turn them into blanks. You just change this, you save the original posted, and you just make changes, but don't lose the original, because you just go back to the original and just make changes, and this will work every time. The key is these formulas. Right there, here's the objective function value. We know it's, where's the optimal solution? When we have the optimal solution for x1, and we have the optimal solution for x2, it's 5 times however many of that, plus 7 times however many of that, and the formula right here, even though I haven't checked, should be this cell location times that cell location plus this cell location times that cell location. And it's E10? E10, is that 14? E14 plus F10, F14. Now if we have 3 variables, obviously it would include that cell times that cell being added. If we have 4 variables, it would be that cell times that cell, and so on. You get it? So that's where that came up. And because I'm bringing this up today, it's because, you know, you have an Excel question in your future, and you'll see a picture of a spreadsheet like this, and it'll say, this is a 2-variable problem. What would you type here if you were using Excel to find the objective function value using cell locations? And we should be at a point where we should decide if dollar signs need to be used or they don't need to be used also. I don't know. I don't think it matters on this cell because we're not copy and pasting, but does everybody understand what I'm saying? That's how the objective function is calculated. It's always the number with the variable in the objective function times the optimal solution. Here's where the optimal solution is going to show up when we solve this. Now here are the constraints. Here's the right-hand side. This is going to be our left-hand side. So let's go to the PowerPoint and look at the first constraint, and then we'll interpret it, make it into an Excel. The first one says less than equal to 6, and all it is x1. So whatever the optimal solution for x1 is, wherever it's at on that spreadsheet should be put also down there on the left-hand side, because when we use Excel, we're telling it to look at those cells and determine if that cell location is less than or equal to 6. So look here, this cell right here. Now it's taken E7, constraint 1, the number with the first variable times the optimal solution. The number with the second variable, well, there is no second variable in this constraint, so we just have a 0 there. And it would be times the optimal solution here, but 0 times anything is 0. So all that's going to show up here is whatever 1 times the optimal solution for x1 is, which is exactly what this says. 1 times the optimal solution for x1 needs to be less than or equal to 6. So before we look at the second one, this would be the number 2 times whatever the optimal solution is for x1 plus 3 times the optimal solution for x2 less than or equal to 19 The 2 and 3 have been placed up there, so we're using cell locations. Before I go into that cell, right here, the left-hand side of constraint 2 is going to be this cell location where the 2's at, the number for constraint 2, times the optimal solution here. So it should be E8 times E14 plus F8 times F14. And that's how you take these objective function constraints and plug them into this spreadsheet. It's these formulas right here, and that formula is where most students kind of have the biggest trouble kind of figuring out what should be there and there. And that's probably where the quiz question's in. What would you put here? What would you put here using cell locations? Okay? So, can you have this in front of you while you're taking the quiz? Yeah, it's open book, it's open note. If you can download your phone, I think these will open up on your phone, won't they? Give it a try. You know, as long as you can logically figure out what's here by looking at your phone. All right, you ready? Now, you've got this all plugged in. You've got your numbers that would be with the variables in the constraints. You have your objective function numbers. We have zeros where the optimal solution is going to be because we don't know it yet. Got our left-hand sides of each constraint, and we're going to use Excel to solve it. I put on here that what I'm about to do is step by step in your book on page 89. Right there, step by step, what I'm about to show you is listed right there. So if you are eventually someday going to have to solve some of these using Excel, so I want to make sure you knew how to do it. You go to Data, up at the top, left click. Go over here to Solver, left click. It opens up this window asking a bunch of questions. Where it says set objective, I don't see anybody writing notes because a lot of people go, wait, it says set objective. You know, another question that could be in your future is, here's the spreadsheet, this is off to the side. I'm going to say, what would you enter where it says set objective? What should be there is the cell location where the objective function is going to be calculated. Let me say that again. What should be there is the cell location where you want the objective function to be calculated, which would be what cell location? Help me out. E16. So I'm putting E16 there. There we go. Is this a max or a min problem? Max, so left click on max. Okay, it says by changing variable cells. By changing variable cells. That's kind of confusing, but really what it's asking is, where are the cell locations where the optimal solution is going to be placed? Everybody hear that? That's really what they're asking for. That's right. We only have 2 variables, so there's only these 2 cells. We're going to tell it E14 through EF14. And it's E14. It has been several months since I've used this, and I can't remember if it's colon or semicolon. I'm going to try colon. Huh? Oh, yeah. Yeah, let me do that. That's even easier. Okay, I've got the pointer in there. I got it clicking. I can just left click here, sweep it across, and it was a colon. And I threw in the dollar signs for fun. If this were 3 variables, I'd go across the 3 or 4. So I don't have to type it out. E14, F14, or E14 through F16 or 17, depending on how many variables. But it's what I want to point out, it's wherever the cell locations are that will have the optimal solution. That's what goes in there. That's what you need to make a note of so you remember what in the heck it's asking for. Because it just says by changing variable cells. It doesn't say where is your optimal solution cells at. That's really how I would have worked it. Now, here's the hard part. These constraints. Subject to the constraints. You want to add a constraint. So you click on add. And it says cell reference. Well, the first one is right here at E20. Basically, when it says cell reference, where's the cell location of the left-hand side of the constraint you're about to add? The cell location of the left-hand side calculation. For the first constraint, that happens to be right here at E20. So I'm just left-clicking on E20. Open up the pull-down. Let it know, is it less than equal, greater than equal? What other options? Equal, and forget the, in this class we're not doing the integer or the bin or the thing. You might see it in your other class, but you ready? This one is a less than equal, I think, isn't it? Is the first one? So I'm going less than equal. Constraint. It's basically saying where's the cell location for the right side of this constraint. Where is it saying 6? Well, we got it right here. Right there. So I just click there and it puts in, what is that, J20. Now we put, I think we put OK. And there it is. E20 less than equal J20. We got one of our constraints there. Let's add another. I'm going to go a little faster. We got 3 of these. Ready? Add. Cell reference, the left-hand side, right here, E21. Pull down. I think that one's also less than equal. I think these are all less than equal. Is that correct? Going to constraint, which means the right-hand side, which is there at J21.
You can
Click.
just hit add and move on to the next one, if you want.
I know. Yeah.
Oh.
Well, hang on. I'm not at that point yet. I'm going to show you even a better trick than that one. So hang on. There we go. I'm going to add another one. Left-hand side, pull left less than equal. Right-hand side. What happened? Did I do it okay? All right, okay. Now look, all 3 of them are there, right? E20, E21, E22, J20, J21, J22. And we're done there. Right, here's a shortcut. Not that shortcut that she thinks she's about to see. Even a better shortcut. Let me delete these. Delete. 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 All right. Add. The left-hand side, since they're all less than equal, you can sweep all 3 of them at the same time, and there they all are. E20 through E22, they're all less than equal. The right side then would be J20 through J22, and you can do it all in one statement because they're all less than equal. You can combine all the less than equals together. You can combine all the greater than and equal together. If there's equals, you can combine those two. Little shortcut. Personally, if if you're using this the first time, do each individual one, because you can make a mistake. But all the left-hand sides are from E20 to E22, less than equal to J20 to J22. Little shortcut. Now, you've got to have this box checked. I don't know if you're writing notes here. The box says make unconstrained variables non-negative. Remember when I said we never have to write out the constraint variables are greater than or equal to 0? By checking this box, it takes care of that. It knows that all the variables are going to be 0 or above. They're not negative. In this whole class, for the whole semester, that will always be the case for every problem. All the variables will be non-negative. And then you've got to switch this to simplex LP. Usually when I open this up, it's at GRG nonlinear. Go to simplex LP, linear programming. Okay, I'm going to scoot this over because it goes fast. All of a sudden you see that it's calculating every possible number here to figure out within seconds what the optimal solution is, and then it covers it up and says, are you okay with this? But you can't even see it. So it's going to go fast. Are you ready? Yes, that fast. Say okay. We should be making 5 of one frame and 3 of the other. And sure enough, we'll go to the PowerPoint. Let's get to the optimal solution. Whoops, whoops. And there it is, 5 and 3. 5 of one frame, 3 of the other. Now we know how to use Excel to solve these. Do you want to try another? One more? Or we only have just enough time for our earning class? What? Huh? You want to get at it? It is kind of a more intense one. Everybody feel okay? Do we have a quiz tomorrow? I can't remember.
No.